Today we were going to do some vintage gaming on this TRS-80 Model 1. I was really looking forward to it because I have never used a TSR-80 before. Had heard about them, knew about them when I was a kid, but never had one. I got this when I was thrift shopping, came with a box, picked it up for like 25 bucks Canadian, which is like next to nothing. Then I plugged it in. It said untested, probably because they didn't know how to hook it up. It only has an RF video output. But then I plugged it in and turned it on, nothing. Completely dead, nothing. No picture, not a thing. So then I opened it up and started looking around to try to figure out what was going on. On the insides, I'll just take the lid off here. Right here is the spot where the transformer lives. You can see it's not there right now because this was our problem. Originally, I took it out to check, the basic stuff, like the fuse. And the fuse had blown. So I was like, oh, great, it's just a fuse. So, went and got a new fuse, put it in, turned it on, and the picture came up. It was all screwy. Here's the old transformer here. So the picture came up, it was all screwy and stuff, and I thought, oh, great, we'll have to take a look at something else and whatever. So I turned my back for a couple of minutes to do something else, and all of a sudden I'm like, what's that smell? That smells like smoke. And I turn around, and there is smoke billowing out of this transformer. I wish I had it on camera because it would have been great. I'm going to put in an artist rendition from my 7-year-old daughter of the incident in which the smoke was billowing out right here.
Oh my gosh, look at all the smoke.
So I'm like, okay, the transformer's gone. So I unplugged everything, took it out, and started testing it. And the leads that were coming off of here, which are the actual power that go to the motherboard, were shorted. So I'm assuming the transformer coil is gone. I started looking around to see if I could find a replacement transformer. And there's nothing. There's nothing for this anymore. Probably is, I could probably buy some used parts somewhere. But there was no option. So I went looking for some help. So I went to the More Fun Making It Discord server. I'll put a link to More Fun Making It's channel in the description down below. Go check him out. Lee is awesome. Does great videos. But he has a Discord server where there's a whole bunch of people on there that know so much about all these retro computers and everything. One person just jumped in and started helping, and it was great. JC1980 on Lee's Discord server was a super help. And what they said is that most likely the transformer coil had shorted, or CR11 on the board had messed up and caused the transformer to short. So I'm not putting that other transformer back into this machine because that'd just be silly and potentially dangerous. What they suggested was to completely replace the transformer and the power circuitry on this side with a brand new switching power supply. This one right here. It is a RPT-60B, and what it does is it'll output, so the transformer converted the AC to, think about 18 volts, and then send it into the board, and then the bunch of the circuitry on here converted it into plus 12, minus 12, plus 5, and minus 5. Brilliant person, this JC1980, looks simply at the schematics and said, okay, remove this, and this, wire these points to here, and you'll be done. That's what we're going to do today. We're going to take the board out, we're going to remove the components that they said to remove, and we're going to try wiring in this bad boy and seeing if we can get it to work. Is this going to work? I don't know. Is this going to be fun trying to find out? Yeah, probably. So let's see if we can get this board out of here, and let's see if we can get some work going on it. So it looks like we got some Phillips screws holding in stuff. So let's first go with the Phillips screwdriver. Well, I guess we'll have to take this shield off and see if there are any screws underneath. Oh, and there are. And wow. This is interesting. There are tons of little bodge wires on the RAM, and there is a bodge wire going over to what I think is the CPU. So and there's a completely different ROM chip, it looks like. So I'm going to assume that this is probably the an early days. The badge on this machine said 4K of RAM. I'm going to assume that this has been upgraded from 4K to something else. Won't know until we actually get the machine running. But yeah, you can see, I think there's a jumper here that says 4K and 16K. Yeah, so there's a jumper here that says 4K and 16K, and it's moved from 4K over to 16K. So I'm assuming, and there's another one over here that's marked 4K and 16K, and it's been moved to 16K. So I'm assuming that this machine has been upgraded to at least 16K. So we'll have to wait till we get the machine running to find out, well, does this upgrade even work? There's a separate ground wire bolted to the bottom here. Let's see if we can disconnect the keyboard. There we go. That'll make things easier. Okay, so now we have to get all of these pins out. Wow, this is excessive. Now, luckily, it seems like these pins are not removable. So when you pop them up, they don't come out all the way. So you don't have to worry about losing them. I'm sure you can get them out all the way, but all you need to do is get them just lifted. And some of these are easier than others, so I would say that this computer has been out of the case before and probably been worked on. So I wonder what kind of bodge wires we're going to have on the bottom. Not quite out yet. All right, here we go. Okay, so the idea for this from JC 1980 was that we would inject the power from the power supply at a couple of different points, actually 3 different points in the board. There was, where's the point here? There's a bunch of test points. There's TP9 here. So prior to TP9, it comes from another device, another component on here, and that's where we would inject the plus 12. And then there's test point 10, which is, I believe, where the minus 12 will go, and then there's a couple other ones where the plus 5 goes, but the power supply does not generate a minus 5. So what this plan does is uses the existing circuitry, because the way that the circuitry worked before is it went from 18 volts to 12 volts, and then the 12 volt line was separated and converted down to 5 volts and minus 5 volts. So what we're going to do is the same thing. We're going to take the line from the plus 12 that gets generated on here and send it into the point where the minus 5 gets generated from the minus 12, I believe. So we're going to take the minus 12 to the minus 12 point on here where the minus 12 gets generated into the minus 5. So let's get out the plan and see where we need to go next. Okay, so the first piece we have to remove is CR11, which is right here. I'm super excited about this because I got a new desoldering gun. So this should be a lot easier than doing it with a soldering iron and just regular braid. So let's just see how this goes. That was cool. That was super simple and super easy. First piece down. So now, from the 12-volt rail, we have to remove C7, CR14, and U17. So we got to remove C7, U17, and CR14. And CR14, the output side of it, is where we are going to wire in the plus 12 from the power supply. Let's add some fresh solder to the ground side and see if that helps take it out. Or I could melt it and just pop out the other side of the capacitor, because the one side is probably pretty free. Oh, not quite. So this is the ground point here, and of course it's tied to a great big ground plane that goes around the whole thing, so it's just sucking up the heat right away. It's melting pretty good, so let's just see if we can do this. So I'm just applying a gentle amount of pressure, pulling it from the bottom. There we go. The capacitor, C7, has now been removed. So now, U17 is these 3 points right here. And these screws. Okay, and there's the second one, and there's the 2 screws, the 2 bolts, and that's not quite undone, so let's, and there we go. So these pins here are CR14. So the one side came out. Oh, there it goes. There we go. That CR14 is out. The components for the minus 12 rail is C9, which is this guy right here, CR15, which is that guy right there. Let me point to him right here. So this one right here. And then you've got U18, which is right here. So this time, I'm going to take that screw out of U18 first. There's C9's out. There we go. CR15 is out, which you didn't see because it was off screen. So I've removed CR15. That popped out pretty clean. So now I just have to finish getting U18 out. There we go. So there's U18 removed. Okay, so the components for the 5-volt rail are, the biggest one is the C10. That's got to come out. I got CR12, CR13, C10 of course, Q2, Q3, U13, R66, and CR17. But I think they're all down in here somewhere, and I think we need to get rid of C10 first in order for us to be able to see what's down there. C10 is out. That's a big bloody capacitor. Q3 and C10 and R66 are removed. So Q2 is this guy. So that'll clear up a lot of stuff off the board. So C10, Q2, Q3, removed R66. So there's CR17, it's right here. So U13 is this chip, and it is socketed, so removing it is the easiest of all. So we're still looking for CR12 and CR13. Oh, CR13 and CR12 are on the transformer? Oh yeah, there they are. So those two guys hold on. So there they are right there. So those two guys are CR12 and CR13. So I don't have to remove those because they're on here and this is already removed. Since I didn't have any of the matching connectors to go with the connectors that came on the power supply, I swapped them out for some screw terminals. So that'll make things a lot easier for this installation. So we're almost at the point where we need to put the board back in the case in order to hook up the power. But what I'm going to do is I'm going to wire up 3 wires for the plus 12, the minus 12, and the plus 5. Blue, red, and black 20 gauge wire. Electricity is not my thing. I think this will be good enough to run, but if you have any comments about how much gauge the wire should be to carry 12 volts and 5 volts, and obviously I'm going to trim them off. So we will use the red wire for plus 12. The plus 12 point on the board is the output pin of U17 that joins up to TP9. So every time if the wires are connected, you'll hear a beep. So here is U17 and here is TP9. So I put one lead on TP9 and then check to see which one of these, and it's that one. So this is the lead here that goes to TP9. So this is going to be our first solder point for the 12 volt rail. Put a little flux on the wire. And I'm going to feed it through here. So that's the first one complete. Next we need to do the minus 12 volt rail, which I think I'll use blue for. Put a little flux on the wire. Okay. And that is going to go into the output side of U18 that joins with test point 10. Test point 10 is all the way up here. So there's test point 10 there. And U18 is, I'm going to have to zoom out to get both of them in. So U18 is here, and test point 10 is up here. So, again, multimeter in continuity, test point 10, and U18. Oh, looks like we got it the first time. Okay, so the 5 volt rail goes from the side of R66 that goes to TP12. So here's TP12, so this is the 5 volt rail test point. And here is the former location of R66. So it's not that one. It is that one. So this is our 5 volt rail. So that's our 5 volt rail solder point. So now what we need to do is we need to hook up the minus 5 volt rail. The power supply doesn't have a minus 5 volt rail coming off of it directly, so we have to use the circuitry that was still on here in order to take the plus 12, or the minus 12 volt rail, I believe it is. Yeah, takes the minus 12 volt rail and converts it down to minus 5 volts. So we're just going to reinitialize that, or set it back up again, by connecting a wire from where CR15 was, so that the minus 12 supply gets to U19 via R67, is the instructions that I was given. Okay, so here's CR15 right here. This is U19 right here. We need to find out which side of CR15 is connected to R67. I'm going to assume it's probably this side. And just to double check, we'll try this side. Nope. And I believe it's marked. That's looks like that's the ground side, so it's going to be this one here. So this is our wire point for the additional minus 12. Got the motherboard back in, screwed it all down. I do have to make one small case modification, and that's removing this post. This is where the old transformer board used to screw down. I've got the power supply sitting on a little plastic board just so that it doesn't touch anything. I've got the AC lines trimmed off and connected to the power supply. So now what I'm going to do is I'm going to plug it in and just check the screw terminals to make sure that I'm getting the proper voltages that I'm supposed to be getting. Nothing exploded plugging it in, so that's a good sign. AC terminals getting 120 volts. This is a common. So this should be +5. This should be +12. Yep. And this should be -12. I'm not sure how that's going to show up. Oh, there we go. There we go. -12. Okay, so all the voltages are working. Okay, here we go. So this is the -12 connection. Red is our +12 connection. And black is our +5. Okay, so I wired up a quick common wire just to one of the ground points. Okay, here we go. Powering it on. No picture. Okay, so multimeters on voltage, DC. Something's not right. Okay, I've disconnected the 12 volt lines. I just want to see if I'm getting 5 volts out. 5 volts. Okay. Connected the 12 volt line, and now we have picture. A whole bunch of screwy pictures, but pictures nonetheless. Problem's going to be probably in my reading of in my interpretation of the instructions for the -12 line. Okay, I think I might have figured it out. I'm not sure if this is right. I'm not sure if this is right at all. You guys will be able to tell me if I'm right or if I'm wrong, because that's what that comment section is for. Okay, so the instructions that I had for connecting the -12 to the circuit in order to create the -5 was to create a link where CR15 was, so that the -12 goes to U19 via R67. So here's R67 here. I checked the connection between CR15 and R67, and it was connected to CR15 on this side of the resistor. So that's where I put my wire. And that did not work. That didn't work at all. Totally messed up all the voltages. Everything went crazy. So just as a hunch, I tried putting the -12 on the other side of R67. And when I did that, this is what happens. We get crazy screen. And then, if we check our voltages, so hooking up there, so we check this one is our +5, which is +5. This one is our +12, which is +12, well, 11.82. And this was -12, which we've got -12. And then this is also -12. And this one is also -12. And then if we check our test points, so TP9 is our +12 test point. So +12 is getting into the system. TP10 is our -12 test point. And there's -12 getting into the system. TP12 is our +5 test point, and we're getting +5. And TP11 is our -5 test point, and we are now getting -5 in the system. So voltages are fully and properly restored. Since there's no power switch anymore, I installed an inline switch on the power cord so that it at least can be turned on and off without having to unplug the cord. So it's maybe not the most elegant solution, but it's definitely one of the easiest. So basically I just cut a little section out of the power cord, just took the coating off, wired up the neutral and the positive to the switch, and the ground just feeds through down here. So the ground just fed right through, and then these two are tied into the switch. So that's a basic little inline switch, about as basic and about as simple as I could get. Now I just got to find the cover. Where did I put the cover? Here it is. So let's just put this cover on. Here are the screws. There we go. So now we have a way to turn the power on and off without having to unplug the actual unit. So that's going to be very helpful. So now we have this computer completely turning on and off again, and we have this nice new switch installed. So that's going to be it for this first part of this series of videos on the TRS-80, as we finally got it powering back on again after the transformer that came in it smoked. So stay tuned for the next set of videos, and we'll keep going until we get this machine fully working again and fully restored. Thanks for tuning in. We'll see you in the next one. Bye.